अच्छा KP का कर लेते हैं this one. अच्छा, we did. I guess we did a few questions of KP. So hang हो गया. See hanging. Let's do more questions of KP. So this question. He's saying, I think this is about the Haber process. So this one is what reaction. Let's start with the first question. I mean, that's not about the first part is not about KP, but he's talking about the Haber process, and the question is like why, with reference to Le-Chatelier principle and reaction kinetic state, explain one advantage and one disadvantage of using a higher temperature. So you got N2 plus H2, and it's an equilibrium with 2 NH3s, and the enthalpy change is minus 88, I think, kilojoules per mole. Now, higher temperature, which reaction will be favored? According to Le-Chatelier principle, the exo or endo at higher temperatures, which reaction gets favored?
Endo.
Yeah, that's going to be endo, right? And remember, the endo in this case is the backward reaction, because the forward has a negative sign. That means the forward is exo.
Okay.
So endo, which means the backward reaction is favored. So is that an advantage, or is that a disadvantage?
Disadvantage.
ये disadvantage है क्योंकि the yield of ammonia will decrease, right? The yield of, you wanted to make ammonia, so you're not actually getting ammonia. So that's your disadvantage. What's your advantage of using a higher temperature?
Faster rate of reaction.
Yes, so so that one is, just 1 second. So that one is a faster rate of reaction. So I just ask the KP expression for the Haber process. That's going to be partial pressure of NH3, and that's going to be squared, and divided by the partial pressure of N2 multiplied by the partial pressure of H2, and that's going to be cubed. Okay, that's your KP expression. Now, as that's your KP expression. Now the thing is that Abu keh rahe hai, this is where you have to calculate KP. So again, N2, you need to make a table, N2 and H2, and it's 2NH3. Now in this case, you obviously have to calculate partial pressures because this KP expression will have a unit. So you can't use moles directly. You have to calculate partial pressure. The initial moles are given that you added 2 moles of this and you added 3 moles of hydrogen gas, and they were put in a vessel and left to reach equilibrium. So initially there's nothing, there's no ammonia. Those are your initial moles. And then he says that what he says is that at equilibrium, the total pressure was 2 times 10 power 7, and the mixture contained 1.6 moles of ammonia. So you got at equilibrium. So at equilibrium, you've got 1.60 moles. So how many moles of the other substances that you have? You've got no moles of ammonia. Now you've got 1.6. So how many got produced? 1.6, right? So 1.6 moles got produced. So how much H2 must have reacted to produce 1.6?
2.4.
According to the ratio, it's 2:3. So 2:3 accordingly, that's going to be 2.4 reacting over here. So वो moles कम हो जाएंगे, they'll decrease, right? And how much N2 would have reacted to produce 1.6? It's 1:2. So यहाँ पे how much N2 would have reacted?
0.8.
So 0.8 will be gone. So your equilibrium moles for H2 will be 3 minus 2.4. That's you had 3, now 2.4 have reacted, so you're left with 0. And you had 2 and 0.8 are gone, so you're left with 1.2. So you've got these moles now. Acha, is this part clear? Onad, is this clear?
Yes, sir.
Yes, sir.
So the next thing that you have to do is you have to calculate now you have to, because he gave us the pressure of the entire container at equilibrium. That the pressure of the mixture at equilibrium, that's 2 times 10 + 7. So you got to calculate individual pressures now. So how do you calculate the pressure of N2? That's going to be the mole fraction. That's 1.2 divided by the total moles. I mean, these are your total moles at equilibrium. So it's 1.2 divided by what? क्या होगा? That's 3.4.
Yes, sir. 3.4.
Times 2 times 10 ^ 7, right? And then the partial pressure due to H2, that's going to be 0.6 divided by 3.4 times 2 times 10 ^ 7. And the last one is the NH3 one, that's 1.60 divided by 3.4 times 2 times 10 ^ 7, right? So, and then you have to do the other stuff, which is that you have to plug it in the expression. So can you try and figure out what, and the expression was PNHT squared. And it was getting divided by PN2. And PH2 cubed. So tell me what do you get?
So for the pressure of nitrogen, it's 7.06 times 10 power 6.
So this is 7.06. Tell me the final answer, like.
Oh, final answer. Okay.
And you have to be very careful with your calculators for this one.
Sir, मेरा 1.0 into 10 power -6 आ रहा है.
Whole thing, right?
Sir, एक second. Sir, एक second.
ठीक है.
Sir, मेरे 1.07 into 10 to the
10 power क्या?
no, it's 3.03 into 10 to the power -20.
3.3 times 10 power?
3.03 into 10 to the power -20.
-20. So I don't know if that's the correct
No,
one.
sir. I rechecked. It is 2.85 into 10 to the power -13.
-30 में पहुंच गए. कितना 2?
2.85.
2.85 times 10 power -30, right?
Yes, that's my final answer.
अच्छा, कोई और भी check कर ले. I don't know if that's the correct answer.
Sir, negative 13.
About about to reach it, sir.
Sir,
हाँ जी
sir, to the power of negative 13 आ रहा है 1 3.
अच्छा 1 3 sorry. Anyways, by the way, what could be a shorter way of doing this? Like it's a very long calculation, especially on your calculator. So one way, I guess, because there's a few things that are common: 2 times 10 power 7 and divided by 3.4, right? So वो अपना it's going to get cancelled out as well. You got 2 times 10 power 7 divided by 3.4. So what you can नहीं वो फिर भी लंबा हो जाएगा. I mean, you can just do the same old-fashioned way. ठीक है. There's no shortcut. So Hunaid, did you get this value?
About to, sir. I'm plugging in the values into the equations.
Okay. And the unit is Pascal's -2, right? So मैं बस ना वो one second.
So was the power -13, sir?
-13, 2.85 times 10 power -13.
Yep, got it.
Achha, but be very careful about these calculations. You got this other expression, and the good thing is that achha, this one. In this case, I don't know what the reaction was. Let me just. This is the reaction, I think. It's given over here: 2HCl, and Cl2, right? He's saying that HCl decomposes in a sealed container. So let's do this one quickly. HCl decomposes to HCl decompose in a sealed container. And he says that there's initially there's 0.30 moles of and 0 of these and 0 of these, right? So that's you got HCl decomposing, and that's your initial moles. And he says that the resulting equilibrium mixture was found to contain 1.5. So at equilibrium, you've got 1.5 times 10 to the power -2 moles of Cl2. So that indicates that you got, I mean, these many moles got produced, right? 1.5 times 10 per -2 moles, they got produced because you had 0 initially, and now you've got 1.5 times 10 per -2. So how many moles of H2 would have been produced? Like there must have been a reaction and moles of Cl2 got produced. So how many moles of H2 would have gotten produced? कितना होगा इसका?
Same value, sir.
Sir, उतना ही होगा.
ठीक है, same. And what about the moles that would react of HCl?
3.3 into 10 power -2.
ठीक है, that's going to be 3 times 10 per -2 moles, right? But they would be, so यहाँ पे add हो रहे होंगे because they're getting produced. Over here, they would be reacting, right? So how many moles will be left of H2? That's going to be 1.5 times 10 per -2. And how many moles of HCl would you have left? You started off with 0.3. These are gone. So what are you left with? You get 0.27?
0.27, yes.
So these moles. So you found your equilibrium moles. Then next he's asking you to calculate the mole fraction. So that's easy. Okay, what is the mole fraction of HCl? What are the total moles? What are the total moles do you have? You've got 3 moles, right? 0.3 moles. That's the total moles. Okay, 0.27 and 0.015 and 0.015. I think the total moles are 0.3. So the mole fraction of HCl, that's going to be 0.27
Yeah, 0.3.
divided by 0.3, right?
Yes,
That's
sir.
the mole fraction of H2 and Cl2 will be 0.015 divided by 0.3 as well. this one would be exactly. So what are the values that we're getting? पहले का क्या 90%, 9.9, 27 divided by 30, that's
0.9, sir, 0.9.
9 over 10, that's 0.9. So this would be 0.05.
Yep.
So anyways, we figure out the mole fraction. As anyways, to find the Kp of this reaction, do you even have to do the whole mole fraction and partial pressure thing, or can you find directly for this equilibrium?
No need, sir, because they're same on both sides. 2.
So it's not going to have any units. So mole fraction multiplied by the whole pressure thing and finding the partial pressure, that's irrelevant. Okay, that's just an extra step that you don't need because it's going to get cancelled out anyway. So, but anyways, they did actually give us, and in the next part, they actually told us the mole fraction. He's saying there's another experiment, there are different conditions, and he's asking you to calculate the value of Kp. And nowhere did he give us the pressure. I don't think anywhere in the question he gave us. It's not mentioned. Pressure is not mentioned because you don't even need pressure to calculate the. The reason this question was tricky was that most people who always knew that you find mole fraction multiplied by pressure, they'll be searching for pressure and they won't find pressure in the question. So that's why it's important that you know that when both sides the number of moles are the same, you don't even need pressure to find the Kp value. So it's just going to be Cl2 and H2 divided by 2 HCl. So it's going to be 0.06 squared. And the bottom part will be 0.88. And that's going to be squared as well. H2 into Cl2 and HCl squared. Is this clear?
Yes, sir.
Yes.
So there's no need for pressure. The question did not even give us the pressure. Kya answer kya hai?
4.65 into 10 power negative 3.
0.7?
Yes, sir.
And no units. Right, so that's your value of Kp. And he actually told us that, I mean, they actually gave a question on this. Explain why the total pressure of the system does not need to be known for Kp to be calculated for this experiment. The pressure value gets cancelled out. In Kp expression. Give me just one mark. And the last, what did we do in the previous one? Actually, in the previous one, you just had to write the expression. Calculation yahan pe karni thi. So just see above, that's it. So we're done with this question. So here, let's continue tomorrow. We'll just do more questions. We're done with Kc and Kp, both of them. So we'll just try and attempt more questions tomorrow as well. Okay,
Okay, sir.
okay everyone. Take care, Hafiz.
Perfect.
Thank you, sir.